Morning, guys. Are you here?
Yes, ma'am.
Morning. Okay, so I'll advise that you guys should switch off your video. Otherwise, then it uses a lot of bandwidth, and it makes it very slow. So please switch off your video. And then also, if there are any questions, please type the questions in the chat box. Don't, so that then I can, look at all the questions at the end, and then I'll just answer them as much as I can. Is that okay?
Yes, ma'am.
All right. We have just one more minute, and then we'll start. We'll start. All right, students, I'm not sure if you guys can see me, but I'll switch it off shortly. Oh, it's quite bright. Okay, let's see. This way. It's extremely bright here. All right, so I'm going to switch this off. I just wanted you guys to see that it is me and I'm alive and all that. I hope that you guys are all fine, so I'll put this off now. But okay, so just a little bit of a ground rules moving forward. Can you all please mute your microphones unless you want to ask me a question and then I acknowledge you, because otherwise then I hear the background noises from a couple of days ago. I had a meeting where I was hearing dogs bark and things like that. So if it's not a problem, please mute your microphones. Okay. Basically, so this obviously becomes the order of the day now. It seems as if we'll be, doing this from now on until we have some sort of direction with regards to where COVID-19 is taking us. But nonetheless, we're just trying as much as possible to get our work done. I know that it's not easy. I know a whole lot of, including ourselves. Look, hasn't been easy. We haven't done online lecturing, and we hardly ever did. So the challenges is not just to you guys alone, it's also to us. But with that said, I think working together, we can, collectively reach the objectives of the module. And of course, then you hopefully get to graduate, whether you'll have a normal graduation or the one in absentia, nobody knows. But so long as you graduate and you can move forward, that's the most important thing. All right. Can you all hear me? If you can, please give me a thumbs up in the chat. I'm not sure if Zara, if you guys can hear me, can Zara respond? Zara? Respond to conversation. Okay.
Hello.
Zara, can you guys hear me? Okay, great.
Yes.
All right. Awesome. Thank you. All right, guys. So basically, I just want us to take you through what we're going to be doing from now on. Okay, so this is very much an introductory lecture on our online learning from, moving forward. So, of course, we will try as much as possible to have lectures like this, having an online lecture. And then ideally, I want our lectures to be during my lecture session so that we can have some sort of order. But now what will happen is that in the future, if I might just use a TP instead of the lecture, or depending on how, I know that the online lecture is going to be quite cumbersome, and also the workload might just be a bit for everyone. So occasionally, if we want to, rearrange lectures, I'm very flexible, and so I'll try and accommodate as we get along. But I don't plan on us just canceling lectures because we've got to get the work done. So I hope you understand that. Okay, so nothing much has changed. You guys are aware that the first semester is the concrete technology textbook, which is the from the Cement and Concrete Institute. So almost everybody, or you all should have a copy. And then in the second semester, we'll be looking at theory of structures. And that semester, I think, we're not so sure yet. It might be presented by Mr. Mazomba from civil engineering, all right? But I mean, let's not focus on second semester right now. Let's get the first semester done. We're not there yet. We'll deal with it as we get along. All right, so of course you can access using all manner of devices. So it's not really much of a problem. Okay, so like I told you guys in the past, I planned on us having 3 tests because, the concrete technology book is quite thick. I think you can all agree with me on that. But considering the situation now, in all honesty, we don't have much time. So I presume, or in my planning rather, test 1 will cover chapter 1 to 8. And then test 2 will cover chapter 9 to 17 or so, or 16, with the exception of chapter 15, because we don't really cover chapter 15 because it's very much covered in your pricing and estimating. So chapter 15 is a chapter that you can eliminate. We don't do it. All right. So the way things are with regards to the online learning is that the test will be multiple choice because I don't see any other way of assessing you. Now, of course, there will be, the test will be done in such a way that you can do it online. So wherever you are, you can do the test. But I must just highlight that the tests will be randomized in such a way that, let's say me and Zara are sitting next to each other. My question 1 could be Zara's question 100. So if you guys are going to be sharing answers, you're all going to be failing because you'll be giving answers to the wrong questions. So these are types of, systems or options that are put in place to ensure that, the integrity of the test is upheld. Then looking at, if things go well, if for any reason this COVID-19, becomes a history, then we'll go back to our normal test and we can maybe push for 3 tests. I'm very flexible because I don't want to bombard students with too much work. But as of now, we are operating as if we're not coming back as yet. We're operating as if we're doing the first semester online. And as such, we're going to have 2 tests and both of them will be multiple choice. With regards to the second semester test, I'm not too sure. I know that Mr. Mazomba last year, he gave them 2 tests, okay? So whether there'll be a third one, I have no idea, but that is something that he'll discuss in the second semester if he takes over. If not, then if I do it, then there'll be 2 tests or 3 tests. I'm more than flexible to operate with regards to, or, to work hand in hand with you guys to see how best we can tackle that. The November exam is multiple choice, as you know, I've told you before. It is 4 hours. And I guess maybe ideally, if we have test 1 and 2 multiple choice, then you can get to have a feel of how the final exam will be. But the final exam is about 4, is it 4 hours, 4 or 3 hours? I'm not too sure, but I think it's 4 hours. I've given 4 hours previously. And I do remember that the moderator was not very happy with me giving so much time, but I think not everybody's good with numbers. Well, the students that are very good with the structures part are not good with theory and vice versa. So giving that extra hour, accommodates and compensates, all the learning abilities. Okay, so of course, I hope that you guys are following on Moodle or I hope you've downloaded this week's documentation. Hello? Can you let me know if you're following the document that I'm using? Because I'm going through the introductory lecture. Zara, can you indicate? Perfect, so everybody's with me. All right, let's see if I can share my screen, because I think maybe that might just be share screen. Okay, perhaps that might be interesting. All right, so can you see my screen right now, Zara?
No, I can't see anything.
You can't see my screen. Okay, that's very strange. Okay, this one. This one. Can you see my screen now?
Still not. Okay, yes.
Still not.
It's coming up.
Okay, yes. Okay, great. Awesome. So basically, if you're looking at the mark formulation, it's the same. Nothing has changed. You need your 40% to get into exam and so on and so forth. It's very much the same thing. All right. You have my email address. You know how to get me. So far, we're going to be using MS Teams for our live lectures. And if you need a one-on-one session with me, you can always just send me an email and I can have a one-on-one online session with you. I really don't have a problem with that. Right, you know the basic, the textbooks that we have, it's nothing for us to worry about. And by now you all know how to use Moodle. Okay, so basically, if we look at what we've covered thus far, we've done chapter 1, 2, 3, 4, 5, 6, 7, and 8. All right, and I do know that we stopped at chapter 9. We're about to start chapter 9 or so. You guys were supposed to cover it yourselves, but I'm going to go over chapter 9 nonetheless. So if we look at chapter 9 to the end, all the way there, so all of that will be done online, and we're planning to get it done in the next couple of weeks. So basically, this brings us to the end of the plan, or our online plan so far as the semester is concerned. Okay, are there any questions that you have? Let me answer it before we go on. If there are any questions, can you let me know? No? Okay. If there are any questions, you can just type them down in the chat and then I'll just answer them later. All right, so let's proceed. Now, I do know, I mean, we've had a couple of weeks sitting at home. You were supposed to be going over your work. But as a student myself, I also know that I never do. So when I was studying and I had to do work on my own, or we were expected to read, I never did. So I'm assuming that most of you did not go over the work we did, and I hope I'm wrong. But nonetheless, I just want us to review what we did before the lockdown. And also, it's vitally important that this is literally a summary of chapter 1 to 8. I know that I received an email from a student that told me he left his textbook on campus or at the res or something of that nature. So that's why I put this together, to almost like summarize chapter 1 to 8, to give you an idea of, you know, the most important points within those chapters that you're supposed to focus on. Even though this is not cast in stone, it does not absolve you, it doesn't stop you, it does not prevent, it's not supposed to be a substitute for reading the textbook. So you're still supposed to read the textbook irrespective, but you know, this is just a summary of each chapter. Look at chapter 1. Chapter 1 is very much the basic, what is concrete. I think everybody is aware of that. We know that it's a mixture of cement, you know, aggregates and the likes. And then of course, why concrete is used so much. So as we get along, these are the outcomes. These are the things that you're supposed to know per chapter. All right, so just if you have forgotten or you don't remember or you just want to recap, so you can take your book and just highlight or make a note as we get along with this particular section. Okay. Then, so that in a nutshell is actually chapter 1 in itself. It's very simple, understanding what concrete is and then why concrete is used extensively. However, also the when you look at the reason why concrete is used extensively in your textbook, there are various reasons, but you don't necessarily have to know them all. But having a broad idea of the reason why concrete is, you know, one of the most used materials will suffice. So sometimes it's not everything that you need to memorize. Some of these things are things that you already know. remember that normally in our lecture, I ask very practical questions, or I tend to get the guys that have worked on site, because concrete is very much site-based. It's like construction technology. Once you've seen it, once you've been on site, it's very easy to understand and it's very easy to apply. So it's very important that at all times, try and put yourself on site and try and see some of these things without necessarily having to spend so much time just memorizing things that you may not remember. All right, then the next chapter was chapter 2, which is sustainability, or the sustainability of concrete. Now, very important, when we deal with sustainability, you've got to be able to explain what sustainability is. I think I've highlighted that in the past as well. We're also supposed to look at the life cycle assessment, the carbon dioxide emissions of concrete, and then concrete's contribution to the environment, or to a sustainable environment. We know that the carbon footprint of concrete, if you look at the entire world, is relatively very big. It's quite large. I mean, everywhere you go, it's just concrete structures and so on and so forth. But to what effect are all these concrete structures in relation to the environment? So it's very important that even though concrete is used extensively, but we've also got to understand that we've got to look at sustainability. We've got to give something back. Some of you have children. You've got to think about, what are you going to leave for your children? What kind of world are you going to leave for your children? I know everybody's talking about this coronavirus being a nightmare. Of course, it is a nightmare. I mean, in the sense that there's no cure, there's no treatment, and so on. But I don't know if you've been watching the news. I don't even watch it because it's quite depressing. But they've been actually showing that from the time of the lockdown until now, the difference in air quality, if you look at countries like India and China even, their air quality has improved so much. So there hasn't been much pollution. And I don't know, maybe sometimes I kind of like think that this is Mother Nature, trying to cure itself or trying to get itself back because of all the misdeeds of human beings, or all our activities that is polluting the earth. So who knows? But I mean, the construction industry is not exempted. We contribute significantly to global warming, significantly to pollution. And at a point, we've got to start thinking about what we're going to leave behind. And not for us. We are here now, look, 50, 40, 50, 60, 80 years, if we're lucky, 50 or so, 60 years, we'll still be around, but God willing. But what happens to those that come after us? So we've got to start thinking at least along that line. So when we look at sustainability, of course, what you need to know is you need to be able to define it, okay, in whatever definition there is. But of course, we always look at the United Nations definition, which is fine. But whichever definition you decide to use, it's okay with you. It's not a problem, because I mean, the definitions will more or less be the same. The wordings may be slightly different. Okay, guys, I'm hearing noise. Whoever it is, please put off your microphone. Please put off your microphone. Okay, guys, I can't continue until the microphones are off. Okay. Okay, let's get back. All right, so now when we look at the carbon dioxide emissions with regards to concrete, all right, or if we look at the impact of concrete in itself on the environment, then we've got to look at what makes concrete, the ingredients, the various ingredients in concrete, and how they all contribute to having an adverse effect on the environment. Can I don't know who this, somebody's laughing, somebody is, I don't know, it's really disturbing. I can't proceed. Constable, is that you? If it's you, please switch off your microphone. Okay, let's proceed. Guys, I'm not trying to be rude or anything, but it literally, if your microphone is on, then all I hear is the background noise and nothing else. So it's very difficult to proceed. All right, so looking at cement, we know that cement is an ingredient in concrete. We know that aggregates are admixtures and water and so on. So now in the production of cement, we need to look at how we can actually reduce the amount of energy that is used in producing it. So we look at the production of Portland cement, we look at the production of cement extenders. Now, when we get to cement extenders, we know that some cement extenders have beneficial properties, but at the same time, some cement extenders also they have the ability to reduce the energy consumption within the concrete itself. So looking at cement on its own, what is important there is how we reduce the energy used in making cement, how we reduce the energy in making cement extenders. If certain cement extenders are used, what are the benefits of those cement extenders with regards to sustainability? So in studying, when you look at chapter 2, please focus on that. When we get to aggregates, right? Aggregates don't just come up on their own. They are sourced, they are broken into sizes, various sizes, etc., etc. So the process in making aggregates, right? We need to look at how we can reduce the amount of energy. I mean, to get aggregates from a supplier to a site, it's got to be driven there. To get the aggregate from the quarry to the supplier also requires some sort of energy. So what are the processes? What can we do in order to reduce the energy consumption? Then again, do we really need to be mining or do we need quarries that much? There's so many materials that can be recycled and used as aggregates, right? We need to start considering some of these things. So this all forms part of the sustainability that we're talking about. And then add mixtures, and then the last one is water. With water, you all are aware that we currently have a water crisis at the moment. So we've got to survive. We need clean water to drink, but water making concrete in itself, if we don't have enough water to drink ourselves, remember that water for concrete needs to be should be the same quality as the water that you drink. And if that's the case, then we've got to consider perhaps using recycled water, harvested water, etc., to try and have a positive impact on sustainability. Okay. Let's proceed. So that covers chapter 2. So we move over to chapter 3, which is cementitious materials. Okay, so far, are there any questions? I'm not... Okay, so I see a lot of thumbs up there. Let me just check. Turn off your mic. Thank you. You're telling someone to turn off their microphone. Thank you so much. All right, so I don't see any questions, so I'm just going to proceed, guys. Right. We're back. Can you still see my screen? Zara, can you tell me if you can see my screen still?
I can see it now.
Perfect. All right, so we're going to look at cementitious materials. You're all aware of cementitious materials. We're talking about Portland cement. We're talking about the cement extenders, the fly ashes, and all of that stuff. All right. We know that cementitious materials are the binding agent in all the ingredients. Without the cementitious materials, then you have the various materials just, in their particles, just in a bowl or whatever. But with the cementitious material, it's the glue that binds them all together. So imagine having sand, aggregate stone, and having, or rather coarse aggregate, and having maybe an admixture to it, and even having the cement itself. So you'd have just all of these ingredients together, but they're not sticky. They don't stick to it. Once you add the water So it's the water that kickstarts obviously the hydration process, which makes it makes that gluey sticky paste. Moving forward, we know that we have various cements. We have common cements. We also have masonry cements, and we have cement extenders. Guys, you've got to be very careful. Sorry. Excuse me. You've got to be very careful that certain cements are used for certain things. So don't confuse this in a test. I know that when it comes to multiple choice, sometimes it gets extremely confusing, or you're all familiar with how Dr. Becker asks questions from his DCO first year. So my multiple choice is structured like that, and so basically it's very easy to get confused. But nonetheless, you need to be able to understand the specific cements and what they're used for. You should also know just a few of them, not all of them. Like we have the CM1, CM2, and so on up to 5. We have masonry cements. You need to have some sort of understanding with regards to the types of masonry cements. We know that some of them have admixture, cement extenders in them, and so on. All right, and then of course having the extenders themselves, being able to differentiate between the GGBS, the fly ash, and the condensed silica fumes. Okay, so I'm not going to go over all of this in detail. I've actually uploaded this document on Moodle for you. I just wanted to just highlight what you need to know. So obviously hydration, understanding what that is, how concrete sets and how it hardens. This is something that you all should know. Also being able to explain the dormant stage, the setting state, and the hardening stage. Now, I'm not redoing the lecture, but I'm just giving you a brief overview of the various chapters that we've covered already. So all of this has been done previously. It's just a matter of just touching base with what we've done. Setting and hardening again, yes, please do note and don't forget the fall set and the flush set, the brief mix, and whether, very important, when you look at a fall set and flush set and even a brief mix, right, you've got to be able to understand or explain it or be able to demonstrate whether, if you have a flush set or a fall set, is there anything you can do about it? Can you improve it in any way? That kind of thing. So having a broader understanding of these things is important. Zara, please make a note. You're going to tell me later on or send me an email or no, on a WhatsApp message. Just remind me to send videos on a flash set and a fall set and maybe something like a brief mix. Even though I've uploaded some videos already, but that will be for next week. But I haven't done anything for this, so I'll just upload it as we get along. Just if you can remind me, then I'll do that.
Okay.
When we get to specifications of the cement extenders, what is important, I don't know if you guys still remember this. I showed it to you in class some time back, and you kind of like took photos. So this is looking at the effects of cement extenders in fresh concrete, and then the other one was in hardened concrete. So we have bleeding, you have setting time, cohesiveness. I'm not going to go over it. This is for your benefit. You can go and have a look at it. But literally, the effects of cement extenders on fresh concrete is important. But remember, the other one is on hardened concrete. So you've got to have a look in that too. Then, of course, the water cement ratio. We know that for a cement mix, all right, so if you look at the CNCI mixing method, there's actually recommended liters of water for specific quantities of concrete. But I mean, that is something that we will look at when we get to the CNCI mixing method. But for now, you need to obviously just be able to explain what a water and cement ratio is, and that's about it. All right, so then we move over to aggregates. don't know if we'll finish all of this before the time, but nonetheless, let's go. Aggregates, we look at their properties, the characteristics, influence of aggregates on the properties of concrete, and then the sources of aggregates. All right. We know that we have fine aggregate, coarse aggregate. Everybody knows that. We know that the aggregates are distinguished based on their sizes. So when we look at fine aggregates, it's anything that is less than 4.75 millimeters. And then, of course, if it's more than that, then it is coarser. Then it obviously becomes a stone, right? Now, aggregates makes up a good percentage of the concrete mix. And as such, I mean, even concrete in itself, making concrete has to be economical. You cannot use more of one material than the other. You can't use more cement than the other. You'll be wasting money. So it's got to be in proportion based on the mix design, and it's also got to be economical. It's got to make economic sense. If the engineer has specified a 20 MPa concrete, it does not make sense for you to go and produce a 40 MPa concrete. Well, you'll be giving a concrete that is way over specified, but at the end of the day, is it economical as a contractor or whoever you work for? You'll be wasting money and nobody's going to pay you for that kind of thing. All right. So if you look at aggregate characteristics, now this is where it gets interesting. We have these characteristics: the grading, bulk density, particle. All of this, you have to know it. You cannot select a few and focus on it, or you cannot take the ones that you can remember and focus. Unfortunately, ladies and gentlemen, you have to know them all. Okay, now I just wanted to bring to your attention that for test 1, I will not include the finest modulus calculation. Let me repeat that. For test 1, I will not include the finest modulus calculation. However, for test 2, because we're going to do the CNCI mix method, right? It includes soil analysis. So we'll do soil analysis there. We'll do it in chapter, I think it's chapter 12 or 13, I'm not too sure, but we'll do it when we do the concrete mixes, because we'll make reference to the soil analysis. And because of this, there's no point in doing soil analysis for test 1 when it will actually be in test 2. And in test 2, it actually makes sense because you use the analysis to continue with the calculation for your CNCI mix method. Is that okay? So just remind me, as soon as we have a date for the test, Zara, you're going to have to remind me that I've actually said the soil analysis is not in. I tend to sometimes forget these things and put stuff into test when I say it's not in. Anyway, so looking at if we go back, just to go back, if we look at the aggregate characteristics, guys, all of these characteristics, as I've said, you've got to know, okay? But also, we've got to know the influence of aggregates on fresh concrete and the influence of aggregates on hardened concrete. They are two distinctive influences, so you've got to be able to distinguish between the two. They're vitally important. Okay, I'm not going to go through all of that. Let's look at mixing water. Mixing water is as simple as that. The water's got to be clean. It's got to be same quality as portable drinking water. There are various guidelines with regards to harvested water or just recycled water and things like that. And then, of course, I have an understanding of industry wash water. I think when we did this chapter, some of the guys that are on site, I don't know if it was Clausen that mentioned it, but or I can't remember, but nonetheless, the mention was made to, normally on a site when you have your concrete truck arrive on site and after the concrete has been discharged, they actually just wash out the truck with a bit of water. Now that water is also used, and it can be used for mixing concrete, which is fine. I know that in certain areas in the country now where there's a drought situation or problem with drought, water is a problem. Butterworth, the Karoo, and so on. So mixing water for concrete has become now almost like a new gold. To get water now is something more expensive, yet previously it wasn't the case. All right, chemical admixtures is the next one. With chemical admixtures, we know that the name of the admixture tells you what the admixture does. So don't forget that. If you have a dispersing admixture or a retarding admixture or an accelerating admixture, the name should give you an idea of what the admixture is. Again, these are some of the things that you don't have to memorize it and break your head, you know, just understanding it, all right? And just remembering that the name is actually what the admixture does should suffice and shouldn't be much of a problem. So you should actually know, understand the uses of admixtures, why we use them, what we use them for, and of course then the types of admixtures. But I mean, as I said, if you know the name of the admixture, then you're obviously going to know what it's used for. So here you've got to have just a good understanding of the various admixtures. Properties, chapter 7. Now, when it comes to this chapter, we looked at consistency, workability, settlement and bleeding, plastic shrinkage, loss of slump, water and requirements, and then special tests. Right. Now, when it comes to consistency, you've got to be able to explain what consistency is, and then of course the slump test. Now, the slump test in the cement and concrete is the book, the concrete technology, the one we're using. That slump test is okay. I mean, it's quite detailed. The procedure is easy to follow. So that's the kind of slump test that I want you to follow. And it's very similar to the one in the how-to of building. If I'm not mistaken, it should be the same thing. So such a question, if it's a written question, it's about what, 15 marks or so? But even in a multiple choice situation, you've got to be able to pick out the various steps from a dozen of options. So hypothetically, if I gave you 30 different options under slump test, you've got to be able to pick out which of the steps comes first, which of the steps comes second, third, and on it goes up until the end. Or you've got to be able to pick out which of the options is specific to a slump test or specific to a cube test, that kind of thing. So you've got to be able to understand the slump test. Again, I'm trying not to spoon feed too much or to give you too much. So some of these things, don't wait for me. If you can go online, get a video, find a video. If you're not sure, you can just email me a link. Let me check it out. If it's good enough, then we can just share it with everybody. So nothing stops you from taking the initiative. I mean, we're third years now. It's the first years that need spoon feeding kind of thing. All right. Even under normal circumstances, I shouldn't be doing this test one review because you see in a senior students, and as senior students, you kind of like, captain your own ship. But this health situation is nobody's fault. And as such, I just want to try and make the transition from normal classes to online as smooth as possible. Workability. All right, so you guys will read through this yourself. Settlement and bleeding. Guys, when we got to this point where we had our lecture, we looked very much at settlement. We looked very much at bleeding. We looked at what bleed water is. I can actually see the students that contributed during that lecture. I can see them now, but I just can't remember their names. Plastic shrinkage as well. So for those of you that don't have the textbook, at least you're going to have this these slides. But like I said, it's not enough. I did find out if I could scan the document through. Unfortunately not. So students, you guys can work something out, sending pictures and whatever, but as a lecturer, I cannot do it because we're bound by certain policies and so on. All right, you should be able to explain what a slump loss is. And of course, if you have a situation of a slump loss, what you can do and what you cannot do. I mean, I think some people just add water. You know, water is an ingredient in concrete, but sometimes it's so abused. You know, it's put in excess, and then of course, if you use more water than necessary, the water cement ratio is affected, the strength is affected. If you use less water, your workability is a problem because it becomes too hard or too stiff. You can't work it, and on it goes, or it becomes too harsh. So yeah, you should be able to explain slump loss. Water requirement that you can go through yourself, and then the test. Now, when it comes to this test, I think during the lecture, if I remember correctly, I sent you videos of a VEEP test or flow test. Either I sent you the links or we watched it in the lecture. I think we watched it and I still sent you the link. All right, guys, you should be able to describe the procedure in conducting a VEEP test or flow test, a slump test or a cube test with the apparatus that are used. So you cannot, you know, start writing a story as if you are in a play. It's got to be procedural, right? And then of course, without the apparatus, then how does a person conduct the test? So for in a test situation or whatever the case is, you must always try and answer questions as if I don't know what you're talking about. Yes, I'm your lecturer and I know it, it's fine, but you must write your answers as if you are teaching me. So when I read it, I should be able to conduct this test myself. So if you use that as a guideline, you shouldn't go wrong. Okay, let's go over. I think we're going to be doing the last one, which is strength of hardened concrete. And with this one, this becomes this is actually where we finished this chapter and then we had this lockdown situation. But anyway, when we look at strength of hardened concrete, we look at time, we look at the compressive strength as well, the tensile strength. We looked at, you know, factors that influence strength of concrete. What you need not to forget, ladies and gentlemen, is the intrinsic and extrinsic factors. Those factors are so confusing that you can actually mix them around. Okay, so bear in mind that if we're going to deal with strength of hardened concrete, firstly, we deal with the cube test. Now, the cube test ideally is, we have our SANS code for the cube test, but you have certain occasions where the cube test is not enough and then you need something else, a core test. You should be able, and I explained it, so I'm not going to explain it again, but because I want you to actually go do the homework, to go and find out if you don't remember. So under which circumstances do we do a core test? And if so, then what do we do with the tests of the cube and of course with the test of the core? Which one supersedes the other and so on and so forth? So you've got to be able to have such understanding.